Hello! Today we're gonna have fun writing some tests, especially for Solana programs. And I'm gonna show you how you can make your tests actually 10 times faster. So we're gonna go from 10 seconds per running a test to only 1 second. And yeah, for that we're gonna use Jest and Bankrun. So usually, like when you write Solana programs, you usually test them using Mocha, which is a testing framework, and Shy, which is an assertion framework, which means like you can say like expect value to be 5 or something like this. And yeah, there's some other options. So there's Jest and Bankrun. So I'm gonna show you first how you can migrate a test from Mocha to Jest, in case you want to do that, and then how you can use Bankrun to run your tests locally way faster, and you can also warp time. So we're gonna do this later as well. We're just gonna manipulate the time and then call the program again and see if the time in the program actually changed. And you can also override some account data, which is very useful, especially for games, for example. If you have like a unit that wants to walk somewhere, it makes sense that you're in the test, just forward the time and then see if the values are correct. So for that, we're going to use one of the presets. So in Solana, you can use create Solana dep, which creates your Next.js app and an anchor program, and create Solana game, which creates you also a Next.js app and Unity client and an anchor program. And in these, you can run the tests with anchor tests. So what I did here is, first of all, I started... I used npx create Solana game and called it my project fast test. And now I can enter this. Yeah, first I need to go into the folder. So this is the fast tests. And what I can do in here now is I can start this client. So this is the Next.js client. And here you can see what this program does. So it's not very complex, but you have like basically a tree that you chop, and you have energy that refills over time. So you can see I connect my wallet and I can click this button here, and I'm spending 1 energy and I'm getting 1 wood because the little beaver is like chopping wood and he has energy. So later we're gonna test like this energy refilling by just changing the clock in the program. But first of all, we want to run these tests, right? So I'm in the program folder here, and I'm gonna show you these tests here. So first of all, you see that there's some warnings here. This is because we first need to install the JavaScript packages. And while this is installing, this was quick. Okay. See, now you can see that all these warnings are gone. There's just one warning left, which is this one. It's searching for target types fast tests. And this is actually the IDL of our program. And so to fix this problem, we need to build our program. So whenever you build anchor program, it will create an IDL file. And it will also create this IDL as a JSON file, and will also create a TypeScript representation of your program. And this will then show up here in these types in just a second. And these types then you can just use in JavaScript to interact with your program. And let me, while this is running, walk you through the program here. So the first thing is we get this anchor provider. Then we set the provider, and then we have this program here, which has all the functions of our program. This is basically the types that we are currently generating here. Then we need, of course, a key pair that we can use to sign transactions. And then we have some seeds for PDAs. So we have a game data PDA, which has the tree and the wood, how many wood can still be chucked. And then we have the player account, which has the energy, the wood he already collected, and when the next refill will be for his energy, and so on. So then the first thing we do here is we get an airdrop in case we don't have enough sol. So this is important if you want to also run them against DevNet or mainnet, for example. Then we get this PDA here. So here we find the player data PDA, and then here we can see we use the program and the program's methods. Then we call init player, we put in all the accounts that we need, and then we call RPC, which sends the function to the RPC. And in our case, in the test, it will send this function actually to our Solana local test validator. And yeah, then we confirm the transaction, and then we do another 11 jobs. So we go to the tree and we call 11-time job tree. And then we confirm this transaction, and in the end we are getting the player data account and we are printing it out. So as you can see, the test doesn't really test too much. So what you can do now is you can do expect decoded dot energy to be 9 or something like this. So I'm gonna show you this later in the Jest tests. But for now, let's call anchor test. And as you can see, we are currently running it against DevNet. So if we go here to the anchor toml, we can set this to localnet. So now the test should run. And I would like to show you, explain you like what is actually happening here. So what if you use the command anchor test, what anchor does in the background, it starts up a local validator and deploys your program to it, and then runs the test against that using the environment variables that it sets in this environment when you use anchor test. And what anchor test then performs is actually it uses yarn run ts mocha, and with the config ts config JSON timeout of 1 million microseconds or milliseconds probably, and then it goes through the tests folder to all the subfolders and runs all the tests in there. Yeah, so that is how that works. You can also change these. So now you can also like have test 2, for example, which has a timeout of 10 milliseconds. And then you can run this using anchor run test 2, for example. But there seems to be some error. Maybe it's because I set the timeout so low. Anchor run. Oh, exactly, that's what I wanted to show you. Good that this happens now. So if we use a different command here, then this will actually not automatically deploy your program. So what you then need to do is to use the Solana test validator, and then you can use anchor build and anchor build and anchor deploy, and then deploy the program yourself, and then these tests will probably run again. So if you want to use this anchor convenience functions of having your own validator, then you should use anchor test. So this is now deployed, and now if we run these, we can see we are going a step further. So this is how you could run these without using the anchor test function. Okay, so but now what we want to do first is we want to use Jest, and then we're going to use Bankrun and make these tests actually 10 times faster. So that's going to be very exciting. As you can see, currently they are taking about 10 seconds, I think. So what we're going to do for that is, first of all, here we create a new folder, and I'm gonna just install, we go through the documentation from Jest. So the first thing we need to do is we need to add some packages. So, and these tests now failed, by the way, because I was already having a local validator running. So now we have a Jest added to our project. The next thing we're gonna do is I'm just gonna go through the documentation here first so that we have a running setup, and then we're gonna migrate our Mocha test to Jest and then to Bankrun. So bear with me here. So did we already create a new folder? No. So first we create a new folder. We call them Jest tests. And in here, I'm gonna call this function as they did in the tutorial. So we have sum.js, which just like is sums A and B together. And then I do sum.test.js or dot.js. And in here, we're gonna add this test. And now, if we do yarn test, we can see we don't have a command yet. So we first need in the package.json add this command here. So here you can also already see that we already have a few different commands. Here we have already lint and fix lint. So, and now we're adding test jest. So what we can do now is we can call yarn test and it will run these tests here. And now what we need to do, like what we want to do is we want to run this TypeScript test here, right? So let's quickly test out if we can actually just use TypeScript here, since I think we're gonna run into some errors. So we have the sum test, but we call it TypeScript now. And let's see what happens. So yarn test, we can see both of them are now green. So that is fine, but we can't find expect here. And let's just try it out. Maybe let's just copy this whole test here and copy it here in our TypeScript file. And now if we yarn test, we should see some errors probably. Yeah, here you can see that it can't find this. It says that there's some missing semicolon here, but this is of course not true. This is because it thinks that this is a JavaScript file, but it's actually a TypeScript file. So what we need to do for that is we need to actually install Jest, which is something that tells Jest how to handle TypeScript files. So for that you can use Babel, you can use some other stuff here, but I want to use Jest. So that is the most straightforward. So we're gonna do yarn add Jest. So just gonna add this package here. It's gonna resolve these dependencies. Then we need to add these type definitions here. So we're gonna add these as well. And you can see that all of these pop up here in the package.json actually. And then there is probably one more. Yeah, we still also need the types, the Jest types. So we're just gonna add all of these. And now I think we should be good. Or I think we are missing still the config. So we can see that there's still an error here. And when we do this yarn Jest here, we also need to create a configuration file, which it says here. And we're gonna create this configuration file with this command. So now we can see that we have a configuration file here. And this one should now tell Jest that we should be able to use TypeScript now. So if I run yarn test, we will see that now we are good. So now we can see we are getting this error here. Anchor provider URL is not defined. And if you remember from earlier, I explained to you that these environment variables from Anchor are only set when you use actually Anchor test. And since we are currently trying to run these tests, we are yarn test, this will not work. So now we're gonna go to our Anchor toml here. And we're just gonna copy this one out for a while and just change this command here to anchor to yarn test. And now if we use anchor test, these tests should actually run again now using Jest. So let's see. It's looking good so far. We got one error. So the error here is now interesting because it says that, hey, you're logging something after the test is done. But where the actual error is that we exceeded the timeout of the test. So we need to also define timeouts for these tests. As you can see here, before we did this like that in the TS Mocha. For Jest, you can do this in the Jest config. So you can do the test timeout should be 10 seconds. And now if we run these should hopefully go through. So the first one was green because this is just a summing up to values. But it's still not long enough. Let's put this to 15 seconds. Oh wait, this is test timeout, not time timeout. Now it should would be nice if it would show me that there's a warning here. So the first one is green, and the second one will hopefully also be green in a second. Yay! So now we're using yes tests actually. But now what we want to do, here you can see, by the way, that all of these transactions here give you a signature, right? But Anchor deletes this test. So a nice tip actually is you can use Anchor test minus detach. What this does, it Anchor now starts up your environment, deploys your program to the local test validator, but then continues running this validator. And this is very nice because now what you can do is you can go to the Solana Explorer. You can put in one of these hashes here, and you can actually look at the transaction. So see, now we can see, hey, the instruction was chop a tree. This is my authority here, and we can see that we have 89 energy left. So yeah, this is very useful. Anchor test minus detach. So keep that in mind. If you just keep one thing in mind from this video, then this is a good one. And now I'm gonna delete this old JavaScript test here. We don't need this anymore. We also don't need this sum thing. So now we have this test here. Maybe we call it, how should we call it? We can already call it what we want to actually do in the end. So we want to change time to refill an energy. So this will be our test now. Energy refill test. Okay, but what I want to show you first is how to make this test faster. You can see it takes like 7.5 seconds, which is like forever. And what we're gonna do for that is we're gonna use a tool called Bankrun. So I'm just gonna Google Solana Bankrun. And I also gonna Google a thing called Anchor Bankrun. Not Bankrun. So this is yeah, Bankrun also can mean running to a bank, but yeah, that's not what we want. So the nice thing what Anchor Bankrun does is instead of starting a local validator, you're directly interacting with a local bank. So you basically, I don't know if it's an emulator, but they are basically deploying your program to the local bank, and then you're directly interacting with that, which is like way faster than sending a transaction to DevNet or to the local validator. So now I installed Solana Bankrun, and yeah, I would probably recommend you to go through these docs first and do this minimal example here, because I'm directly gonna skip the normal Bankrun and use Anchor Bankrun. So now I'm gonna copy this command here, yarn at Anchor Bankrun. And now we have these two packages installed as well. And the nice thing about Bankrun is, like, pretty much all you need to do is replace the provider, the Anchor provider, with the Bankrun provider. So, and to replace this Anchor provider with the Bankrun provider, we're gonna look at this example here in this repository from Anchor Bankrun. And here we can already see how we create the Anchor provider, the Bankrun provider. So we're gonna copy this over here. And yeah, now we don't need this provider anymore. And we hopefully will be able to import these since we already added the correct packages earlier. And now we can see that this is awaiting. So we need to put this actually into our async function here. And yeah, now let's see if we now are able to run this. So this is pretty cool. It is like actually very easy to migrate from one provider to the other one. So the error we are getting now is no such file or directory. So what this means is it's searching for the Anchor root directory, and since we are here actually directly in the program, we don't need to provide anything there. So we can just run a yarn test again. And now we should go to the next arrow. And here you can see already that there is no function get balance on connection. And this is because in Bankrun, many of the RPC calls are actually not implemented. So we don't need an airdrop. So you can't basically use an airdrop. So we need to remove this. And if you ever need a second funded key pair, then you actually need to use these parameters here from the start anchor function. So here you can see we can add edit programs and edit accounts. So in here we can now, for example, just create a new edit account, which has already an initial Lamport balance. And I'm going to show you quickly how this works here. You can find these differences between Bankrun and normal tests here in this guide as well. So here you can see airdrops. So there's no airdrops, but what I can do is I can just create this additional account here, just put it in here. And if I have a second key pair, then you can see now I will be able to use this key pair and it has already a balance on it. For our game, what we could do, for example, we could create another player PDA which already has energy or something. So what we want to test is that the energy refills over time, right? So we have multiple options there. So we could say, hey, we just overwrite the data in the account and set the timestamp from the last time the energy refilled to something in the past, so like to 0. And then so much time passed that we will have full energy again. But I think it's more fun to do this with changing the time actually. So we're going to use the time warp for this later. Okay, let's see. We will probably run into a few more errors of functions that are not available. So this is a bit of a disadvantage that tests are actually Bankrun specific now. But what we can see now, the next function that we don't have is confirm transaction, which makes sense. We're directly working on the bank. We don't send it to a validator, so we don't need to confirm the transaction. So we're going to remove all these confirm transaction calls and run this again. And now we have, this is actually an error I encountered earlier. This is probably not very intuitive, but if you have the exact same transaction that you send multiple times during the test, then they will result into the same block hash, into the same transaction hash, and then it will fail. This is usually when you do a Solana transaction, you're getting a new block hash, a new recent block hash. You put it in your transaction, and it will result into a new, completely new transaction hash. In this case here, we call the same chop tree function 11 times. So it will always result into the same hash. And then the validator would be just throwing it away because he thinks he already processed this transaction. We have an easy way how we can fix this here. We can just, for this second parameter here, we can just use the I from our loop here. And I don't know why the error is actually so weird, unknown action undefined. So I will probably report this to the Bankrun team. But yeah, if you run the tests now, every of these transactions should result into a new transaction hash. And this is now actually working. So now we can see we're having all these transactions here. And we can see the transaction hashes of them as well. And the program ID and all that. You can, by the way, also run these with without all these logs, rust logs equals. So you can just set the environment variable rust logs to none. And then the logs here are a bit shorter. You can find this info also in the Bankrun docs, but I think it's quite nice. Okay, so now what we want to do, now it's getting interesting actually. Now we want to warp the time. So here we, let's expect some value first. So we're gonna expect that our decoded energy is, say, 100, which is wrong, of course, because it should be 89, I think. So now we can see that we are expecting 100, but we're receiving 59. So 59 is wrong. So who paid attention earlier, actually, why this is 59 and not 89? Oh, that's not a live stream. Okay, so this is because this is a hex value. And what we need to do is we need to pass this into an int. And now it should be hopefully 89. Because we start with 100 energy, we chop 11 times. Yeah, so now we are at 89. So now we can put this to 89 and the test should be green. This sounds good. Okay, and now we want to warp time. So let's go down here and see how time warping works. So we're gonna go to the Bankrun docs here, and we're gonna click add time travel. And here we can see how it works. So we just copy this, we create a new clock basically, and we import this. And now it says also we need a client. So here on top, we're gonna create a client. This client is quite nice because it lets you, oh, that's not how it's called. Banks client. This client is quite nice because you can also use it to get account data. So here you can see we are still using the provider connection get account info, which Bankrun implemented, so it still works. But what you can also do instead is you can use client.getAccount and then decode the data in there. But for now, we're gonna leave it like this. So, and now we can see that the last parameter here is the Unix timestamp. So what I'm gonna do, since I don't know how to use JavaScript, is I'm gonna say, please give me a Unix timestamp. And now we're gonna use this timestamp to override the time to some value in the past. In the future, because in the future we will have some time passed and we will have more energy. So this AI feature here definitely still needs some work, I think. But okay, now we have a timestamp, and now we're gonna just add some time there. So we're gonna add 60 seconds. This is wrong because it wants a big int. So let's convert these into big ints. This one as well. Big int. Okay, and now our test is actually, now we should have more energy. So we can just like expect here the time, the energy to be 90. And as we can see, this fails. And this fails because we didn't get the new account data. So of course we need to get the account data again before we do that. So we're just gonna say this is account info 2 and decoded data 2, and this decoded data should be 90 now. Oh, but the data in the account also didn't change that yet. So this will still be 89, because what we need to do now is we need to call the program once more. So we're gonna chop one more tree, and then the value should hopefully be correct now. So if we run this, we are expecting 89, but it's 90. So this actually makes sense because we are time passes for one energy, but then we spend one energy again. So if we now do 60 times 2, now it should be 90. It's still not 90. Because we are using the wrong account info here. So now it should be 90, hopefully. Yes. So that's working. And yeah, another thing we can try out now is like we can use this like times 100. Then it should be 99, because it will be refilling to 100, but we chop one tree and it will be 99. So let's yarn test this again. And it's successful. So now we can actually change time back and forth and do whatever we want. In a game, this is like really cool. If you have like a game like Tribal Wars and you send a unit from one place to another, then you might need to somehow calculate the time. It will be very difficult to do this with the local validator. So yeah, that's already it. I think this is really cool. It makes your tests way faster, like from 10 seconds to 1 second only. So if I run anchor test again, we can directly have the comparison. So you can see it's running, every transactions need to be confirmed, and it takes 7 seconds. So we are like around 7 times faster, but it depends on your tests, of course. It doesn't need to build and deploy the program every time and so on. So there's a bunch of benefits of Bankrun. So for example, you can change account data, you can warp time. It's way faster. But there's also some disadvantages, like it's not exactly the same environment that you would have when running a local validator, or you can usually Mocha test, you can also just run against DevNet. For example, if you want to initialize some accounts or something like that, or you can just copy paste the code and use the same code. So there's some advantages and disadvantages. I'm not sure yet how I can look at these transactions, for example, if I use yarn test. I won't be able to look at them in the Explorer, so I would need to use the command line for that as well. But in general, this is it's a big help. And you can also run them both at the same time if you want that. So you can just go to your Anchor TOML here, and you can say, hey, I want to first run my Mocha tests, and then I want to use my Jest tests with use Bankrun. And if I now use Anchor test, then it will first run the Mocha tests, and then directly after it will do the super fast Bankrun tests. So yeah, thank you for listening. I think this is very useful. Check out the guide if you have questions, because there's some troubleshooting. Like I ran into a bunch of problems converting the tests. So this should be helpful. And yeah, test your programs, and see you next time. Bye-bye.